Hi, good morning, and welcome to this ZP vlog not ZP vlog, but the ZP Developer Zone webinar. So we like to do this really to answer technical questions that have come in during the week. Today is the 7th of December 2023, and this is just answering 7th of December. It's the 10th of December 2023. My apologies, I got the date wrong on that. But this is just really answering some technical questions that have come in during the week. Let me jump straight into it and just say, look, we have the ZP Academy. We have the ZP webinars, we have collaborations, we suggest jobs on the website, and we also have Developer Zone, and we have the workshops. The workshops are probably particularly relevant to today's questions because one of the questioners in particular is kind of interested in implantable sensors. You've got a kind of three levels of difficulty, I would say, in biosensing. The easiest thing to do is spot testing. I sometimes call it in vitro diagnostics or point of need testing, where you have a sample, you put it on a sensor, you get a result. That's the end of the kind of assay, essentially. You then got another tier of difficulty, which is continuous measurement. So question number 2 today will be about continuous measurement. And then you have question number 3, or tier number 3, I should say, which is really measurement continuously within something like a mammalian body. So that's really quite a tough challenge. And all of those are covered in the workshops anyway. But I will answer the technical questions that have come in during the week. I also suggest that the workshops are good. In fact, we do have a workshop in January, and I definitely know that there's also a workshop in March on the 5th and 6th of March. This just demonstrates to you that if you're interested in continuous measurement, or you're interested in continuous measurement within implanting sensors into bodies, then we do have workshops. We do them essentially once a month. This demonstrates that for 2023 we did have them every month. There is a webinar called Sense It All next week, and I very much hope that both people today who have made inquiries actually come to that. If you see a link, by the way, I will put a link underneath this webinar as well. And also, one of the questioners is particularly interested in what actual sensors and solutions do I actually need. So I will have all those linked underneath this video. Once the video's gone live, I'll take all the links and paste them underneath the webinar. We are having a conference in 2024 in the UK, and it will be on the commercialization of electrochemical assays. I just want to put a quick, again, any links that pop up will be going underneath that. This is probably relevant when you're doing implanted sensors. Implanted sensors is not is not, when I say implanted sensors, it's not an effort that you do half-handedly. You really have to go into it, and people really invest millions in working on implanted sensors. So at ZP, we do actually do a very practical hands-on workshop when it comes to things like CGM, that's continuous glucose monitoring, and implanting sensors. So we did a workshop of recent on site with a client. It was everyone constructing what's called a Gen 1 glucose sensor. And if you're not familiar with these terms, Gen 1, then I definitely say that the workshops are good. We also constructed a Gen 2 sensor. We also talked about SPE or polycarbonate substrates for sensors. We tested a potassium sensor. We do the theory of these sensors. Even if the theory is not super necessary for everyone within a group working on an implanted sensor, but it does help to have that kind of context when you're actually working on things. We discussed different electrochemical techniques. These different electrochemical techniques are kind of interesting because questioner number 2 wants to do a continuous system, and actually that means that the electronics has to have the flexibility to deal with these different techniques. We talk about factory calibration versus on-site calibration. Both questioners today will one day have to address this question about calibration. Of course, at ZP, we know how to move things to high volumes. We are ISO 13485. It's quite interesting, actually, because we then do demonstrations on potentiometric sensors, including pH and potassium. We discuss quality management systems and also, obviously, project management. There are 2 questions today. One of them is on implanted sensors, and one of them is on continuous measuring by using conductivity. I think it's urea, pH, and there's one more. Oh yeah, redox as well. So I will cover those questions. I suppose it's worth saying that the whole construction and philosophy of ZP is to say you've got end users, be it patients, doctors, farmers, lots of people who actually could benefit from sensors. And then you've got companies, startups, entrepreneurs who really want to service them with technologies and solutions to problems. And then the whole technology stack and philosophy at ZP is actually to kind of provide as many pieces between people who want to solve problems and people who have problems. So you will see that we have this kind of hardware, electrodes that we manufacture, or biosensors that we manufacture, or hardware that we manufacture, and we're really just trying to get between people who want to provide solutions and people who have problems that need solutions providing to. So that's the kind of whole philosophy at ZP. The other philosophy at ZP as well is we're really good at getting technology actually from the people on the left hand side to the right hand side very quickly. We do that really as part of programs, but then we're really good because we're able to make most of our technologies are all automatically, I say most, all of them are automatically then connected to the cloud, so that we can actually start looking at the raw data from these people who are using the technologies, and actually then feed it back to the people who are interested in providing the solutions. So then that improvements can take place. So we've kind of got this cycle of technologies that go to end users, raw data goes back to the cloud, the engineers and scientists working on those solutions can look at that, and then we can make improvements which then feed back to this. This is really a kind of lean, they call it lean startup, but it's really a sort of philosophy of getting technologies into applications as quickly as possible. Now I understand that one of the questions today is actually interested in implanting sensors. So it's not like you can just go and implant sensors into people just like that, but at least have the philosophy of acting quickly, and don't spend years making something and then finding out it doesn't work. I mean, I know that many people now have this agile is one way of thinking of it, kind of mentality, but we definitely have that kind of agile mentality at ZP. And I'll go a little bit quicker now. Just to say, many of our instruments, even our lab instruments, this is a lab instrument. It's called Kate, but it's actually a potentiostat. So potentiostats are kind of our R&D kit, and it looks just like the kind of hardware then that we actually put into clients' programs. So this, on the left hand side I have a potentiostat, on the right hand side I have something called Sense It All. There's no electronically and mechanically, there's no difference. It's really just the software that actually makes these two instruments different. But one's an instrument for doing research on, and the other one's an instrument for giving to customers as a MVP, a minimally viable product, and actually getting going. And what's nice about that is that in high volume, we're able to do that at $60. So it's kind of, it also answers another business question, which is how am I going to scale my business? How am I going to get hardware? And that answers that question. And any links, as I say, I'll put them underneath the video. So we do have a whole range of sensors. I think approximately 5, 6, 3, 4, 5, 6, 7. Yeah, that's about 38. In fact, if there's another 2 sensors, so there's 40 sensors in the ZP library of sensors. Today I'm going to be talking about, I think one of the questioners is actually interested in glucose sensing when they're doing implanted sensors. One of the other guys is definitely interested in pH and redox and urea and conductivity. So I will be discussing those, but we do have this whole range of sensors. And it really comes back to that philosophy of, if we've got these sensors kind of pre-worked out, then it really accelerates people from, I'd like to determine glucose or urea, for example, otherwise I'd have to go away and make all those sensors. Well, of course, they exist in the catalog. The whole ZP technology stack starts often with manufacturing. Now, today, I'm going to be talking about other formats like wire sensors for implantation, and I'm also going to talk about microneedles for transdermal. But when I'm talking about urea and pH and redox today, I will really be talking about screen-printed the start of our whole technology stack starts with manufacturing, and then we describe ourselves as kind of a sensor to API company. So that means we're really good at the sensors, we're really good at the applications, we're really good at the electronics, and we're really good at the connectivity to the cloud. And then we have a cloud system called Julie. So I did say there's a webinar next week called Sense It All, on Sense It All. Come to that because we'll talk about the Julie webinar then. But just to say, we're really good at this kind of manufacturing part, and everything else is built upon that. Otherwise, if you've got kind of weak foundations, then the whole technology stack just falls over. But Sense It All comes in lots of, it's a catch-all, but we have a spectrophotochemical system, we have an electrochemical system, and we have a wearable system, which is also electrochemical as well. You can find the Sense It All on the website. If you're just buying one, it's 16 or 1700 euros. But in fact, if you buy 10,000, they end up at 60 euros each. So it just scales with volume, really. 10,000 is not so much, is not really that many in business. If you're not able to sell 10,000 of a unit a year, then it's not really a business, let's say. Question number one. I'll get to the questions now. We want to know if these sensors are biocompatible. Does the electrode corrode while operating? The quick answer to this is ZP is an ISO 13485 business. We put our sensors onto people and into animals. Now, the reason I say that is because if you're going to put sensors into people, you have to be really careful about the power supply. So I'll talk about transdermal sensors today, and I'll also talk about implantation. Question number two is they're asking if we've got a reference design. Their priority is pH, redox, urea, and conductivity. What we have is a developer's kit. It's not very well named. It's called the single purpose biosensor circuit. So not very well named. I will link to it. But we basically have a circuit, and it's a good circuit because it can deal with pH, redox, urea, and conductivity. And it's all shielded up and sort of get rid of electromagnetic noise and stuff like that. So I will talk about that today. Question number one is they were really asking, are our sensors biocompatible? And are they, they're asking, do they corrode? So there's a couple of problems sometimes people have is corrosion delamination. I'll talk about it actually because this is a good point. ZP is launched in 2014. The first thing that we ever did was, now I started my glucose monitoring career in 2000-ish, making glucose sensors. So I'm approximately 23 years into this. This company has been running for 2014. So I say this company, a company we launched since 2014. So we've got a lot of experience with making implanted sensors. It's one of the first things that we actually did. We are ISO 13485, so it's not, at the moment, almost like if you've got delamination and corrosion problems, you're almost at the very start of the journey because you haven't yet moved on to the part of the journey where you've got to kind of talk about the quality systems and the sterilization, the aseptic manufacturing. But this is something that we definitely do. So we're a contract developer, contract manufacturer. We have facilities in Norway and the UK. As I say, we are ISO 13485. We make electrodes. The electrodes that we put into our web store, by the way, on our terms and conditions, we do say they're for R&D purposes only. It's because we put the products on the web store almost like a service. Somebody wants to get going. Somebody has an idea. They want to do water quality testing. Once upon a time, to do that, they would almost have to just build everything from scratch. And that building everything from scratch is more than a 5-year journey, actually. And most of the time, you could spend 5 years and really not make any progress. So we put them on the web store. People can buy them. People can try them. People can get going. It's almost like a development start. And we make sensors in generally 3 kind of formats. Planar. Question number 2, when they're asking about pH, redox, urea, conductivity, these will be really planar electrodes. Wire assemblies. I'm going to show you a CGM, continuous glucose monitor, which is a wire that is implanted. And then these 3D needles, these are described as transdermal. But ZP's done a lot of biocompatibility studies on transdermal sensors. We've done something like easily 50,000 hours on these 3D sort of transdermal sensors over the last 5 years. Our manufacturing takes place in an aseptic clean room. So if we're doing sensors for implantation, do understand that we have to do it in a sterile environment, and we're very good at that. These are some of our facilities. Our facilities are really state of the art. Oh yeah, right. So the questioner is do we get delamination and corrosion? The quick answer is no. I have seen lots of companies suffering from delamination and corrosion when trying to make electrodes and electrochemical sensors. It's a common issue. At ZP, it's not a problem that we're having. This is a sensor package based on a wire sensor. So this is the wire. In this package, this is why I was just kind of talking about, you can't just implant things. You've got to think about the power source, obviously. I'm sure that this company is already thinking about the power source. But here we have the electronics. In fact, later on I will talk about the single purpose biosensor circuit. This is a first generation of that. We got a transducer here for sending out the signal, and we've got a power supply. I'm obviously knowing that we're not going to put 2 coin batteries in a person. You're never going to get that past regulatory. It's not even, I wouldn't even do it. I wouldn't have to ask regulatory. It's not something I'm going to do. It's not safe. But we do implant these sensors. Actually, these sensors this kind of form of sensor gets used in mammalian systems, obviously pigs and rodents. But most of our work actually at the moment when it comes to implantation is actually putting them into fish. Now these fish don't look it, but they're actually being operated upon and then stitched up, and there's actually, or sutured is really the medical term for it. And they are swimming around with that sensor package actually in them. So at this moment in time, we've got fish in a RAS system. I think it's a recirculating aquatic system. So RAS, a recirculating aquatic system where these fish are swimming around with these sensor packages in them, monitoring their glucose. I said earlier on that, with sensor to API. So the sensors are powered. We're sending the data out of these tanks. It's going to a receiver, and we're actually then taking the data via the cloud and actually looking at the data in real time. So we are real-time monitoring implanted sensors in fish. Of course, we've had to make sure that these sensors can kind of survive this kind of operation. So these sensors now, this is 125 days, but we've been operating sensors for over 9 months at this point. So if you've got corrosion or delamination, these are really because, I don't know, of the material, well, not, I do know, there's something wrong with the material selection that's being used, and it's not trivial to kind of solve those kind of problems. But at ZP, we have been doing this for quite a long time, and those problems are solved, and we do have robust sensors. Slight change of direction now. Now, this is not implantation. I would call this minimally invasive. So ZP is quite good at minimally invasive. This is microneedles. This is not, in fact, I've got some microneedles up here, but I'm not going to run off and grab them now, unfortunately. But we have these kind of technologies which, and as I reason I show these images, it's not enough just to kind of make sensors. You have to think about the packaging, keeping the whole thing clean, which is what we're good at. But we make these kind of microneedle sensors, and we functionalize them appropriately with the enzymes. We're really good at obviously doing electrochemical detection, but also thinking about interference molecules. The next question when you're working on an implanted sensor is, does it respond to my analyte of interest? And then what other molecules could interfere with it? When I say all of this, ZP, if somebody's working on an implanted sensor, you really have to engage ZP in essentially a proper program, because we have to understand what you're doing. Otherwise, you're putting our sensors into situations that we wouldn't necessarily want you to do, or you're doing things. I wouldn't want to be part of that. You'd have to be engaged in a proper program. This will come up in a little bit, but we do have electronics to drive this. Now, I understand that at this moment there are lots of semiconductor companies who are very interested in making analog front ends for this kind of thing. So we're quite happy to be engaged in programs to help those kind of companies as well. But we do have a set of electronics. I made the comment earlier on. It's just we've obviously, it's not trivial coming up with this, and it's things, little details like the shielding, etc., have all been taken care of. Just of interest, if you are working on implanted sensors, it's not just making the sensors and the electronics. You have to kind of end up making all sorts of test rigs in order to kind of test things and verify things. I realize this one is actually showing an assembly where we're trying to push sensors through the skin so that we can make contact. So that's not implanted, it's what I call transdermal, but you saw earlier on we actually do at this moment have implanted sensors in operation, though admittedly in fish, but the challenges in fish are the same as many other organisms that you'd be interested in. The technology stack stays the same. The biocompatibility problems are similar. And we've got a lot of biocompatibility experience because of well over 50,000 hours on the microneedles, well over 50,000 hours of experience on the CGM. Side note, it's not just glucose that we're good at. We're also able to do other analytes that have interest these days, which, for example, ketones and lactates. We do have a very special, we manufacture in a clean environment, but it's also what we call aseptic, that we're checking it for things like bacteria to make sure that, if you're going to make an implanted device, it's a big thing to actually, you've got to make sure it's sterile. You're really risking people with infection. Now, I'm going to change direction slightly now. This person did ask me to discuss a reference circuit, and their priority is pH, redox, urea, and conductivity. One thing I'd say is, I'll say it as we go along. So let's go forward. So pH, redox, urea, and conductivity. So on the pH, there's a particular sensor here that I recommend, and here's a link to it. Any links that pop up, I will make sure I put them underneath the video afterwards. There's also test solution, because people just come with all sorts of random solutions, and sort of you've got to kind of have a bit of a roadmap on this, where you kind of start simple and get more and more complex. So people just jump into complex. But the first thing to do is get some sensors, also get some test solutions. Again, the URL is here, so I'll put that underneath the video as well. And then on the electronics as well, this is a test board or a developer's kit. It comes with all the cables, and this can drive that particular sensor. We also have ORP, oxidation reduction potential, or redox sensors. Here's the sensors. Here's some test solution. Make sure everything's working okay, because you build something and you're like, well, especially with oxidation reduction potential, it's kind of a trickier one. How do you know it's working or not? Whether pH is easy to measure, but ORP is a little bit trickier. So here's some test solutions. Same electronics. Again, the link will be underneath the video. Urea, same story. Here's some sensors. Here's some test solutions, and here's the link. Electronics, here's the link. Conductivity. I didn't put a picture in here. The conductivity's got the same form factor as the other sensors. These are kind of planar. They kind of got a width of about 7 millimeters, a length of 20 millimeters, a thickness of 625 microns. They're quite small. And here is the test solution that I've also put a link to it here, and here's the electronics. So I'm going to do a little bit of a summary today. So welcome to the ZP Developer Zone. We do like to answer technical questions. Some questions are hard, some questions are easy. The easy one today was really question number 2, which was, recommend, my pH sensor, which I did. I recommended the test solution. I recommend the electronics. I said the same for the urea, the redox, and also the conductivity. So that's quite simple, straight question, easy answer. The other question is much more nuanced, because in the end, these people want to put this stuff into some sort of organism, and it's not a trivial thing, but we're already doing it, and what I can talk about in the public domain. Most of ZP's work is actually doing contract development, contract manufacturing with other companies, so I can't talk about it, but this is something that we're doing internally, where we're implanting a whole sensor package, in this case into fish, and so you have to deal with robustness, which is really deal with their question. They say corrosion, but I suspect they have corrosion and delamination. And then you've also got biocompatibility concerns. So we've had to choose materials that won't basically cause it a sort of an immune or an infection. Well, yeah, infection is also another matter as well. So sterility also comes into it as well. So we've got a lot of experience in that, and we've also got a lot of experience in making electronics to drive those sensors. That's why we don't do a reference circuit, because reference circuits are kind of interesting. At ZP, our business model is to actually provide you with the electronics necessary. You can make also, you can get the data out of this chip, no sweat, sort of UART connection. I2C is all on there. So then you can sort of build your system up from there. So with that, I'm going to say thank you. If you have any questions of ZP regarding implanted sensors, transdermal sensors, making sensors for human health, making sensors for aquaculture, we're very experienced in these applications. And you know, we have materials on the website to try and get people going quickly, but we also do workshops. We also do contract development, contract manufacturing. So if you have any questions, don't hesitate to reach out to us. Okay, thanks very much.